My name is Richard Nuckolls, and I'll be your host today. So we're going over creating and configuring and running data through Stream Analytics service in Azure. Today we're going to be talking about some of the highlights of Chapter 6 of the book. Chapter 6 being on Azure Stream Analytics, a service for handling analytics with streaming data in Azure. If you want, you can see the site, and I think we're going to go ahead and jump right into it. I went ahead and created several other support resources that you'll want to use when you're running Stream Analytics in Azure. Stream Analytics is a service in Azure which supports doing analysis in near real time on streaming data. You've got multiple sources you can use, but they are very tightly integrated with Stream Analytics, those being Event Hubs, Blob Storage, and IoT Hubs, which is really a subset of Event Hubs. So I've set up both a storage account and an Event Hub to support today's streaming session. And I've got some data prepared so that we can run through some of that with you. First thing we're going to do is just get the Azure Stream Analytics service set up. There's several different ways to set these things up. I'm just going to use the Azure portal here because it's pretty easy to do, and it's a bit more visual for those of you watching at home. Multiple ways you can get to it in the Azure portal, of course, and setting up a Stream Analytics job is something we go over in Chapter 6 in the book, Azure Data Analytics. I use a naming convention for the resources that I set up here, and that's covered in the book as well. It's basically covering from broadest to narrowest the various aspects of what this service does, starting with the region, moving into the application use or the system that it's running on, the environment, and then the type of Azure service that it is. And then if you've got multiples of that type, you can run suffixes to show those various differences, and then also ending with a number. But in this case, we're using demo. I'm going to say this is the prod environment, and what we're setting up here is Azure Stream Analytics. I abbreviate that as ASA. You could call it streaming, call it stream, call it job, stream job, if you like. I've got a couple of subscriptions or in the pay-as-you-go-to subscription here. If you've worked with any of the Azure services in the past, you know that we've got requirement for a resource group for every service that you set up. So I've already set up the resource group East US Demo Prod RG. So that's what we're going to be using here, putting all these other services to support this in the East US region. And you can see that's part of the naming convention already, so it's easy to keep track of where all these services are and should be. Stream Analytics does support two different places that you can run the job so that you can actually do processing of your streaming data out on the edge in your IoT device or your IoT gateway device. This purpose, we're going to be running them in the cloud, which is in the Azure cloud, so that we can use a bit broader set of data here. But one of the things you do get if you do choose to run the Stream Analytics on the edge is a direct and low latency connection to that IOC devices that are streaming to your gateway. Well, like I said, we're running in the cloud here. You can set the number of streaming units based on how much data and how many different calculations you're intending to run, the complexity of the calculations, and how much complexity you can get out of them. Today, we're running a fairly small set of data through here, nothing that our Stream Analytics engine and the Event Hubs endpoints can't handle at the lowest setting, so we're just going to be using a single streaming unit. Multiple streaming units come into play once you've got more than one parallel source for your data. If you are targeting blobs, which we'll see later here, you can have multiple files being read at the same time, while if you've got more than one streaming unit. And the same goes with the Event Hub. If you've got more than one partition, of course, we'll have two partitions at least with Event Hubs, but if you've got multiple partitions and you're using partition IDs to separate the data that's coming in for higher throughput, then you'll want to scale your streaming units up to match what you're pushing in from, or what you can pull from Event Hubs. But in this case, we're just running a small set of data through here, so a single streaming unit will be just fine. If you wish, you can secure your data assets here in a storage account. This provides a bit more security over your configuration files, but they're already managed pretty well and securely in the background with Stream Analytics, so it's not something you're required to do. So the configuration files are secure, but this gives you more security at rest for your data elements while they're in flight. So we've got our Stream Analytics job set up here. Go ahead and go take a look at this. So this very easy to get one set up and running. Now the tricky part is, how do you configure it? That's actually one of the nice things about the way Stream Analytics is set up in Azure. Several of the services that Microsoft has set that are more of the proprietary nature are featuring really tight integrations with other services. So they actually are easy to configure, easy to connect, and communicate with each other really well. Now that we've got this set up, as I said, I set up a couple of services in Azure earlier to support running the Stream Analytics. One of those is Event Hubs, which is a high throughput journaling message event endpoint. So you can run lots and lots of data through the Event Hubs endpoint. And once it's in the Event Hubs, you can use it for multiple other sources. Stream Analytics being a very popular one. But you can, of course, have Event Hubs triggering Azure functions, logic apps, and multiple other endpoints, including your own custom code. I've also got a storage account set up here. If you are using file-based data and you're generating file data on a regular basis, then you can drop your files in here, point Stream Analytics at a blob container, and Stream Analytics will pick up the blob files as they are modified and added, as they are added into the blob container, and then read them as stream data into the stream. It's the way to have many batches running through a single stream conduit for doing your analysis in real time or near real time. So now that we've got our Stream Analytics job set up, we've got our input sources. We also want to talk about output sources, where we have a limit of just 3 types: the Event Hubs, IoT Hubs, and blobs. For the inputs, we have quite a few more outputs that we can write back to a different Event Hubs endpoint. We can write to blob storage, and we can also write to SQL databases here in Azure directly. There's a few other interesting things like service queues and service bus topics directly out to Azure Functions as well, if you need some type of programmatic handling of specific sets of data that come out of your Stream Analytics. We're going to talk about both blobs and SQL databases here, and I've also got a SQL database set up for use both in reading and writing. So we'll get to take a look at those things now too. So if you want to follow along, if you already have the live book version of the book, you can look in here. I'm not really going to be actually following along. We are going to be picking and choosing some of the code from in the book, but mostly we're just going to be going along showing some of the tricky parts here. As easy as Microsoft has made setting up services in Azure. There are still some complicated bits and some bits which can frustrate you or just take a long time to get set up and working and understanding. So I wanted to talk today about what I think is one of the more complicated ones. All right, we've got the Stream Analytics job set up here. You're familiar at all with it. You know you've got inputs, outputs, and a query that joins them together. By default, your query selects a couple of placeholder inputs and outputs. One of the really nice things about Stream Analytics is the query is written in SQL with a couple of extra keywords or commands, function calls that you use to configure the streaming nature of the query in the Stream Analytics service. We'll go over that a little bit later. So we've got our query here. We've got no inputs currently, but on the input screen is where you can see and add inputs to your Stream Analytics. So this is where you should start. See, we've got two types of inputs you can add. You can add in the regular stream data stream inputs. You can also add in reference inputs, which are static data that you can load up from different sources, blob storage or SQL database, and enhance the data that you get in your data stream. In general, your reference inputs will be used with a join in the query to the data that's in your stream input. Let's start off with what could be an easy input, could be a tricky input. All depends on if you've got your data set up and what you have for your timing. So all of the inputs need an alias, basically a name, so you can identify them in the query. And because the query uses both inputs and outputs, I find it's beneficial to prefix both your inputs and outputs with a notice that they're either in or out. Let's see, so this is an input. We're going to be running this from blob storage. Call this stats. I've already set up a few files here, and we're calling this data stats coming in. So as you can see, we've already got pretty good integration with blob services here in my Azure subscription. Pay-as-you-go number 2, it's already selected in the drop-down here the storage account I set up, which is East US Demo Prod Store, and already pre-populated securely the storage account key. So I've got access to the storage account now. If I needed to, I could create a new container to run this input off of, but I've already created the inputs that I want to use, or the containers that I want to use for the blobs. Stats input being the container we're going to use. Show you that over here in the East US Demo Prod Store storage account. Got these 3 containers here, and I've already added in input1.csv in the stats input container. Pretty small file. We'll take a look at where our contents are here. Nice thing about working with text files in the Azure portal is that you can, in general, browse and view them in the window. So this is just a very simple set of data in the CSV format. We've got a header row here so that we get friendly field names in our query. And then we've got 4 fields here in some standard formats. Stream Analytics will actually read and do a best guess application of file types or field types for these. And we have a date time in, let's see, I think this is ISO 1801 or 1806 format. A couple of integers and a text, could be varchar, could be in varchar. Not sure what Stream Analytics uses in the background, but I'm pretty sure it's going to be a text-based variable for that field. So now that we've looked at that, it's called input1. We might want to know what the folder structure is like in our storage count blob container if we've got something other than just drop it in the root folder. In this case, it's pretty simple. It's in the root of the container, but if you do have it in folder structures, you can modify your folder structure so that you can input a path here so that it matches your folder structure in the blobs container. One thing to keep in mind is that if you do have folders, start with the folder name. If we had a folder called stats, start with stats. A leading slash on there will actually look for a kind of a weird pattern. So start without the /. One of the things we'll see here in our outputs in a minute is the date formatting that Stream Analytics can automatically apply to your file names. Because Stream Analytics is handling an unbounded stream of data, or an unbounded set of data, the idea of time actually plays a big part in pulling data in and exporting data out, sending data out. And Stream Analytics has made it pretty easy to separate and generate new files while you're running the stream. This pop-up, which you can't see on your screen, talks about, there we go, maybe you can get it on there, talks about adding in the two variables that go into the path. If you want to use them, you can use the date and the time variables and choose a format that you want. If we want to use YYYY/DD/MM in this path pattern, it means we're going to end up with a stats/year/day/month/ then time, which the format will be hours, long hours. I said this is actually an input, so we don't need to check the input pattern or the path pattern for anything other than a file in the root here. But if we wanted to keep separate files in here and only run ones using input name, we could actually put input. I think input star works as well for matching those. The last thing we need to configure for our inputs is the type of file, basically the file encoding that we're using serialization for this file. We've got a few different options. The easy ones to use are Avro, JSON, and CSV. The other ones require a bit more configuration and messing about to get them to work. JSON does work. It's a little bit trickier for deserializing arrays that are subsets or sub elements of the top. But as we saw before, this file is a CSV file, so we're going to be using CSV as our encoding for this file or serialization format for this file. We're using commas, but you can have what's effectively a CSV or a TSV, semicolon, semi-SV, with various types of delimiters here. We're using comma. UTF-8 is your only option, so if you're not using UTF yet, you should probably move away from ASCII to something that's more Unicode friendly. And finally, you can actually use gzip or deflate to keep your file sizes down in whatever storage endpoint you're using, in this case, blob storage. We're not using any compression on these, so we will keep that at none. All right, we'll save that. So the input has been created, and now Stream Analytics is doing a test to see if they can connect, see if the Stream Analytics service can connect to the blob, see if there's a file available there. So we've got this set up here. I want to draw your attention to the right end of these. If we need to, we can run the test again from here. We can delete the input at this point, but probably your most important button to ensure that you've got your input set up correctly is this sample data from input button. So I want to spend a few minutes on that. So if you're just joining us, we have created various services to support Stream Analytics pipeline, and we've just finished creating the Stream Analytics job service in Azure and setting up our first input here. This input is a blob input using a file that we have here in a Azure Storage account blobs container. So the trick to sampling data and making sure that your input is set up properly with a blobs input is modify date. Stream Analytics, when using inputs from blobs, use the modified date to check whether the blob has been imported before. So doing this test, you'll actually want to make sure that the modified date for this file that's in the folder, one or more files that's in the folder, falls within the range that you're testing for in your data sampling. So in this case, this file uploaded at 3:49 p.m. Eastern Standard Time today. So we want to make sure that the range that we're testing for and sampling for contains 3:49 p.m. As you can see, the default here was about the time that I set up this input. I actually want to set that back to an earlier period, and then we can test for a particular duration with this window. 3 minutes is the default, which hopefully should get you a small chunk of data. If you've got a large, you'll grab basically 1,000 events or a megabyte worth of data out of here, or all of the data that comes in through this streaming window. This is one of the first times we're looking at a windowing function for Stream Analytics. So we are going to read data that has a timestamp between 3:38 p.m. today and 3:42 p.m. today. We'll grab 3 minutes and we'll see if this works. This can take a minute or two to run. Sometimes it takes 3 minutes, the whole duration that you've run. Sometimes it will find it very fast. If it finds the data very fast, then it usually comes back pretty quick. Otherwise, it may come back with can't find any data. But this is one of the reasons I felt this was a strong candidate for streaming, because this is one of the more tricky things to get set up and tested and to figure out why is it working or why is it not working. All right, no data. So it says it didn't pick up that file that was already there. It didn't see either because the modified time wasn't in the range or something else. So let's go ahead and upload a second file. So why don't we do thing? We're going to do another sample. We've got 4:35 p.m. here. Let's put Save 3 minutes on there. Make this 4:34 p.m. Start that sample running, and let's upload a file. Here's input 2. Upload that file. We've got 4:35 p.m. 30 seconds. And again, no events found. Well, let's try this one more time. Let's put this at 3:49 p.m. Let's run that window 55 minutes. Let's see if we can get one or both of those files now to pick up. All right, so this time we finally managed to get that window to match. Either I've got the wrong dates in there, the wrong windows. It's not reading my time on my local machine the same as it is in Azure. But this time we were able to sample the data in there. The input 2 here. We've got 5 rows data there. Same for input 1. All right, let's see if we can open this downloaded file up here. And here we go. We've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows here in the captured file. So it captured both files that time, pulled them in, and wrote them out to this sample. So we know that that input is running properly, and we've got data that can be read there. Now we've got a working input there. Let's see what it looks like to create a working output.